Right. Thanks, everyone. Thanks for coming. Well, no one wants to sit in front. It's quite interesting. Yeah. My name is Ilya. I'm not sure if you met me before. I'm organizing this meetup usually with another guy who comes from Sydney, Boyan, but he's on his honeymoon, so he's enjoying probably some quality time in Europe. So I'm a principal consultant at Mantel Group. Mantel Group is a sponsor of this event, and also they provide this venue. I'm working the AWS capability, and I'm also AWS Cloud Community Builder in the serverless stream. So if you want to connect with me, or if you want to present here one day, yeah, just scan this and submit your talk. Yeah, Mantel Group, it's a consultancy, so we do hire people. You can scan, and you will see a few of those posters everywhere. So yeah, just scan them and see if you can find a suitable opportunity for yourself. We do have toilets there. In case of fire, please run either that way or that way. Hopefully doors are not locked. Yeah, all right, covered this one. I will start just with a bit of serverless news. I always struggle with that, but it's probably going to be a very quick 5 minutes update. What happened interesting in the serverless land in the last, I would say, 3 months. We tend to run this meetup every quarter. I'll start with AWS because that's what I'm working on day to day. I'm not sure if many of you followed some news, but there was quite a big topic when after, I don't know how many years of S3 bucket been online, someone actually found out that if you keep sending requests to the bucket you don't have access to, the bucket owner is still getting charged. So they don't charge it for error HTTP codes anymore, which is great. Amazon Open Storage Serverless, which is, in my opinion, is not really serverless because it doesn't really scale down to 0, slashed entry cost by 50%, which is good. Amazon API Gateway also just announced, I think, 2 days ago that they're going to increase the limit of API integration from 29 seconds. And I went actually to the console this morning. I was trying to understand how it's going to work. I think it's going to be quite complicated to, to configure and explain. Also, I think quite a big thing was for if you ever used ECS, that now you can use VPC flow logs and extend AWS extended support for ECS. Cognito introduced tiered pricing for M2M usage, which is a little bit sad. So now you need to pay a bit extra if you're creating your Cognito with M2M authentication flow. Amazon Bedrock Studio, not quite serverless as per se, but it's getting more and more popular. So if you never tried, I recommend at least to have a look. The cloud front, again, I'm not sure how many of you ever used it. It's mainly for the front-end applications. So if you want to have a server-side rendering for front-end applications, you could do it on Lambdas. I just recently had a project where I had to build a Lambda-based backend for Next.js application. That was quite interesting. And in order to do that, you usually integrate your CloudFront with Lambda. So AWS now introduced origin access control, which is great. Otherwise, your Lambdas were not protected. They were basically exposed to the internet as soon as you know how to call it. And yeah, they also introduced resource-based policy for DynamoDB, which is, again, in my opinion, a bit of controversy because I'm not sure about the relevant use cases where you want to implement cross-account access control for DynamoDB. But it is possible now. On the Azure front, I think Azure also continued the journey that I think all other big cloud providers started, making sure that you can use your functions to stream sub-responses. So instead of just using REST API or something like that, now they support streaming in Node.js and Python. It went live in the last 3 months. Azure Functions now can run on Azure Container Apps, which is quite interesting too. I did present last week at the Data Eng Bytes meetup, and I was talking about data APIs. And quite funny that probably Microsoft attended that session too, and they built Data API Builder, basically allowing you to build API on top of the databases as a service. Just a heads up that .NET 6, .NET 7 coming to the end of support on Azure Functions. Also, interestingly, that .NET 6 actually ends after .NET 7, which I found a bit funny. Application Gateway supports IPv6. I think that's also one of the trends that we see across all the clouds. We're running out of space in IPv4. And also, yeah, Azure Functions started supporting Node.js version Feng, which is, I think also we can see happening across all major clouds. Similar Google Cloud, they started supporting a bunch of new runtime versions. I think in the GCP, I always struggle to put some serverless news, but I think GCP is investing a lot into something called Gemini, and that's something, it's their artificial intelligence that they're trying now to basically implement everywhere. You see code assist, cloud assist, security operations, BigQuery, Looker, databases, so allowing you to either use NPL to generate some SQL queries to the database using a natural language, NLP, sorry, and similar with, I think, BigQuery, Looker, they allow you to now interact with your basically data sources using chatbot or something similar. Vertex AI is getting more and more love, I guess, from the GCP as well. It's basically a service from GCP that allows you to build some artificial intelligence and build some models. The ML prediction has been introduced to Spanner, so now you can basically emulate some machine learning on top of or using Google SQL or PostgreSQL. And Cloud Run started supporting direct VPC egress, which means that you don't need to have a serverless VPC access connector anymore. That's pretty much all the news I found for you for today. And I'm going to introduce our first speaker, which is Alan. Alan Blockley, a Presales solutions architect from Thoughtworks. Solutions architect lead, I must say, right? not just. Words in my title. It's not, yeah. And the last one is the most important, right? So, and Alan is an AWS ambassador, AWS community builder. Impressive collection of 12 AWS certificates. Are they all valid?
13 are all active.
13? Okay. Did you get your golden jacket?
My golden jacket.
Yeah. So a truly amazing speaker. And yeah, lots of experience in different areas and in consulting yourself. So welcome, Alan.
Thank you. You all now know my secret magic word. Cool. Okay. Hi, I'm Alan. I'm here to present on Streamline your serverless development on AWS. I don't like walking in front of a screen. It feels weird. Is that better? Can you all see it now? So I'm Alan, as Ilya just introduced me. I work with 3 cloud providers, AWS, and AWS. I'm an AWS ambassador, community builder, subject matter expert, so that means I write the exams. So if any of you sat the solutions architect associate recently, I do apologize. AWS user group lead for Brisbane and gold jacket holder. So that's me, in short. If you want to connect, feel free to Google me. I'm sure you'll find me on LinkedIn. I should have put a QR code up there. So what are we talking about today? The stuff. Yes, there's a lot of stuff, a lot of words on a slide. I hate slides, as you probably know. Hence, I've gone for the classic VS Code, markup language look. If you like YAML, you'll love this presentation. So we're going to talk about SAM briefly. We're going to go through the benefits of SAM. We're going to talk about the components of SAM as well. We're going to go through a quick template example, quick review of what the commands are, and then review what SAM local is as well. There's a lot of content here, and apparently I get the crooked, yank off if I'm not done within like 30 minutes, apparently. Quick look at what SAM can do with pipelines and CI/CD, followed by monitoring, because we've got to review observability as well at the same time. You've got to know what your Lambda functions are doing. Then the security context, and then we're going to go on a bit of a death match with CDK. Ignore the last one. I didn't remove it from the slide. I forgot to remove that, sorry. But what or who is SAM? Oh, SAM's this really cute little mascot here called Sam the Squirrel. But SAM stands for Serverless Application Model. It's a framework that AWS put together to help people get started with Lambda and serverless technologies, API gateways, and other technologies that you might want to use in your serverless stack. It simplifies the process of not only getting started, but managing your serverless stack. It's very much designed to make it easy. A lot of people get daunted when they start to look at best practices in AWS, like CloudFormation, for example, and go, that looks hard. Why do I need all these different resource elements to make such a simple function? And that's what SAM was designed to do, simplify the whole process. The benefits of SAM really stand up for themselves once you've got started. So let me try and help you out here. It simplifies the deployment process. It's literally a single command to deploy into your cloud provider, specifically AWS. It simplifies the management of your code as well. The development experience is consistent not only inside of SAM, so different SAM users can talk the same language, but it's also consistent with AWS infrastructure as code concepts as well. So if you understand CloudFormation, you'll really get on well with SAM as well. It's easier to test and debug. One of the most powerful things I find about SAM is the ability to run a Lambda function on my own laptop. I could be on a flight to Sydney and I can write my SAM code, and as long as I've got my container on my laptop, I can execute my Lambda functions, test them, debug them, write them. I don't need to keep uploading to my account. And then debugging as well. It has great debugging functions. So then it increases the productivity of your development. If you've not got to wait for your Lambda function to deploy into the cloud, for it to upload to S3 and then unpack into Lambda, and then you've got to go and configure your next part of API gateway maybe, you've just sped up your development time, made yourself more productive. And for the salespeople in the room, if there's anyone that's businessy, it's the faster go-to-market. What's in the box? SAM. What's in the SAM box? It's got three main components that you will need to get started. The SAM template itself can be YAML, can be JSON. My preference is YAML because I like pain. You'll need the SAM CLI. It's no different to the AWS CLI. At the end of the day, you download it from the AWS website. There's a link. Feel free to take a photo of the slide. I'll also publish the slides after, so you've got these links available. And then SAM local is the other part of the mix. You'll need Docker. Other container apps are available. Terms and conditions apply. Available at $19.99 for monthly repayments. As you can tell, I'm stuck with Docker at the moment. Let's get started. Let's look at a SAM template. So this bit at the top here, yes, it's mandatory. It's a transform. But doesn't this look like something else that we've all seen in the room? A CloudFormation template. But you'll need underneath your main header of your CloudFormation template to transform it into a serverless template instead. Then we've got this wonderful thing here called globals, description, metadata, parameters. Hang on, did somebody say globals? That's not part of CloudFormation. Globals is a really, really cool function of SAM. It's unique to SAM. It doesn't exist in CloudFormation for a reason, because SAM does it. Imagine being able to configure 3, 4, 5 Lambda functions inside of your template. However, your Lambda function, each individual Lambda function, is only actually 4 or 5 lines at best, if that. Because in your globals, you've just put your environment variables that are common to all functions. You've put your runtime, because it's probably going to be common. You're probably using only one particular runtime. Maybe you've got certain permissions. Your globals are things that are common across all Lambda functions that you're writing in this particular template. So that then also reduces the amount of code you've got to write. Then there's the description, which is pretty, average. Everyone probably puts test script in description, right? Then your metadata parameters, then your mappings, conditions, and resources. Everything else is fairly similar. Just this globals is unique, and the transform to get the SAM template working. Serverless. More like serverless stress. No? Okay, fair enough. I'll move on. So the AWS SAM CLI, as I mentioned, is important to getting the whole thing started, right? So at the end of the day, we've got SAM init. No, that's not an English colloquialism. It is actually called SAM init. That initializes your new application. There is a demo at some point through this, by the way, so please don't feel like you've got to remember all this. Or, imagine it working. Then there's SAM build, where you build your stuff. So we've got build new stuff, build my stuff, and then at the end of the day, we've got deploy my stuff. SAM works on a basis, and I probably need to say this now, that you are already authenticated with AWS CLI as well. So if you're using SSO, copy paste those access credentials into your terminal, or if you're using assume in, but however you authenticate into your AWS account from the terminal, you'd do that first, and then these three. Then there's SAM local. I mentioned SAM local earlier. This is where stuff gets interesting, gets really easy to test, gets really easy to debug. So we've got SAM local invoke. That is where you invoke your Lambda function locally. I want to test this. I want to make sure it works. SAM local invoke, function name. Excellent. It gave me the output, or it didn't. SAM local start API. So generally, a lot of people that are writing Lambda functions, they need an interface to it. So a lot of people use APIs. So that will start a local API to connect to your function. Great, not a problem. There's also other local resources as well that I've not mentioned in the presentation that you can use to help test, and that's like local DynamoDB as well. AWS do have a local version of that you can run, either in a container or as a binary, so that you can also then connect to a local DynamoDB for testing too. So there's other local services you can try. And then there's SAM local start Lambda. Hang on, isn't that what that just did? That just started my Lambda. Difference. This starts the local Lambda endpoint instead. So you could run a Lambda service on your laptop and then connect with other services to your local connection to then connect to any one of the Lambda functions that you've built instead. Just like running a local DynamoDB server. So we've got a local API gateway server, a local Lambda server, and a local API DynamoDB and Lambda. So all of a sudden you've got this little stack that you can test with locally on your laptop without going out to the internet. Quick demo. I've learned the hard way that the demo gods are not kind. So I spent some time in the morning, very early in the morning, just running a quick demo, but I'll talk through instead. So this is me on my machine. Yes, it has a weird name. And I'm just going to launch myself a new SAM project. SAM init gives me the option to use a quick start template or a custom template. In this case, I've gone for the hello world example, because why wouldn't you? And at this point, it's going too fast. So I'll pause it there. One of the things that you'll notice at the top is it asks me for my use case. That use case, in this case, was hello world, but you can also go for serverless API gateway, machine learning, etc. So it will pre-bake certain common sense parameters into your template ahead of time because they're best practices for that use case. It then offers me the most popular runtime package and type. No, it wasn't TypeScript. It offered me Python and zip. So I said no. Instead, here, it offers me the runtimes that I would like to use. Now, actually, I would use Python, but I wanted to show you the runtimes that are available for SAM to automatically assume. That's better. So in this case, we've got good old .NET 6. I think that needs to be deprecated at some point. Java, for those in the room that like Java. I think there's somebody over here that does. Node, Python, Ruby, etc., Rust, and Go. So I've chose 18. I want to use Python 3.11, and I'm going to use a zip type. Now, for those of you that already know about Lambda functions, you'll know you've got two types. You've got a zip file, which is effectively your source code, just injected into the function, which comes from S3. And then you've got the other type, which is a container image. So you can have a container image that's run via Lambda. And so this is asking you, what type would you want to use? So in my case, I'm going to use a zip because I'm old and traditional. Having 26 years in IT, it's a long time. You kind of don't move away from zip files. Then there's a couple of other common sense things here that come up, and I mentioned observability earlier, and this is important. So it's offering me some common sense defaults. Do you want to enable X-ray? Now, if I was doing something more complicated than a Hello World project, I probably would use X-ray. You know, if it's also offering me CloudWatch application insights and also structured login in JSON format. These are all now common best practices to be followed, and these have only been added in the last sort of 6 months. But what makes this really cool is that you haven't got to think about it. It's prompting you. So therefore, no excuse for getting it wrong now. We give it a quick name. I gave it something inventive like SAM Demo API. And then we're going to just quickly run it now. So I've not wrote any code yet. All I've done is launch a SAM in it. And I've asked it to start the API. Now, this is where things start to go a bit curly. So it's launched my API for me on port 3000. And it's saying, warning, this is a development server. Don't do this in production. See, told you it got a bit curly. And so I'm going to try and query my API. Now, at this point, I got missing authentication error, but I left it in there on purpose so you could see what would happen if you didn't hit the right resource. So at this point, no resource, missing authentication token, and then as you saw briefly at the end there, it returned with the hello world. So that API is running on API gateway, Lambda function on my laptop. So what is behind all that? Great question. For that, I have another video. So what I did here is I've just gone through the anatomy of the SAM init project, ultimately to try and explain to you how the SAM projects are built together. So initially, we have the template, template.yaml. Yes, I promised you YAML, you got YAML. And this is ultimately a CloudFormation template using a serverless transform. That's the function. That's all that's needed for the function. That's the only resource we have. Yet it launched an API gateway and it launched a Lambda function. This is our code URI. So ultimately the code's coming from the Hello World folder and our runtime, which could be up here if we wanted to. And then we've got an event. So I'll just pause there for a second and explain what an event is to those that don't know. So an event is, in a Lambda function, you get the ability to trigger it from somewhere. Whether you're triggering it from an S3 event, or whether you're triggering it from an API gateway, you can codify these events against the function itself. So in this case, I've said event, hello world, is going to be an API type of event, and this is my path and my method, which then makes my resource. But I haven't written a single line of code that addresses an API gateway. nor the security functions that go with that. But down here, you'll see, if it highlights it, hello world, function, I am role. It's creating implicit resources for us at the same time. Those implicit resources are the API gateway and the security role to go with it and the security policy. So for one template, I'll just pause it there again. For one template, it's created the Lambda function, the API gateway, the role, the policy. Was there a resource I'm missing? 4 resources for one piece of code. And then there's the app.py. So this is in our code URI folder. It's generated this for me. I haven't written a single line of code yet, but it's given me some best practices again to follow, plus a return hello world at the bottom. That's where I put my logic and carry on. But I can now just go and write my Python code. I don't have to worry about any of that infrastructure behind it. I know it's got best practice security behind it. I know that it's ultimately going to do the right thing by me in only implementing a Lambda invoke security role. And then there's events. So I mentioned testing earlier. When you call a Lambda function, AWS will send something called an event to the Lambda function. That's where all your parameters are. For example, well, we all know what happens with an event, right? It sends the S3 file, etc. You can write these yourself to test your Lambda function with certain scenarios. Sometimes if you don't know how to start with those, send a test event to a test Lambda function, output event, and then copy and paste it into one of these files and include it. So you can make your own as many as you want. Mr. Luxford, how are you doing? Presenting to you the co-presenter, also an no, just kidding. So that's the basic anatomy of a SAM-produced project. We've done no work, but we've got a lot out of it already. That's better. So, another pun, serverless, more like serverless hassle. It worked. I got 1 or 2. So what about AWS SAM and security? Because I mentioned earlier that it will create me a role and a policy. But that basic role and policy will do nothing more than give me invoke access to the function and connect it to the API gateway. So we could do IAM policies in CloudFormation. Because it's CloudFormation, we can write anything that's CloudFormation based. It will accept it. SAM will go, your CloudFormation, I'll just output you at the end. Because that's what SAM's doing. It's synthesizing the serverless transform into CloudFormation. So you can then augment it with full CloudFormation to add further resources. So if you wanted to add Cognito to it, don't know why you would, but you could implement your Cognito code into the SAM template. But that's boring. No one likes SAM policies, not IAM policies and IAM roles, and they're long and tedious and they go wrong all the time. There's the option called AWS connectors, and this is SAM specific again. AWS connectors will allow you to connect a resource to another resource in 2 lines. They're quick, they're easy, but I find they're not as flexible. So then the third option, and this is my favorite, SAM policy templates. SAM policy templates are resource-based and service-based. They're predefined by SAM already. I want a DynamoDB create, read, update, delete role for this resource. 2 lines. But I've got DynamoDB read-only, DynamoDB full access. And there's about, I think, 150 of these so far for differing services, whether it be EFS, so if you want to use file shares, or if you want to give access to S3, there's a long list of these available. We need more of these. There needs to be a Bedrock one of these soon. What about CI/CD? How many people here do DevOps properly? They do pipelines, they do CI/CD. Quick show of hands, who plays with pipelines? Okay. How many use code pipeline and code deploy? Guilty over in the corner, yeah, okay, fair enough. What if you could deploy a CI/CD pipeline for your Lambda function and API gateway the same way you created your original API gateway and Lambda function? SAM has a pipeline command as well. SAM pipeline init will start to create you a full pipeline based upon your code. Easy as. All you do is you give it SAM init, here's my template. And it will go, you want to create a pipeline. It will create you code build, it will create you code deploy, and it will create you code pipeline in CloudFormation, and then deploy that to AWS as well. It will connect to whichever repo you want, whether it be Bitbucket, GitHub, GitLab, can't remember, code commit. I don't know, how many people use code commit in here? That's what I thought. Oh, I've got one, got two, three. It will connect to whatever repo you want, and then obviously detect the changes and do everything that you expected of a code pipeline. But it understands architectural best practices as well. Hang on a minute, how many stages do you want? Do you want a dev stage? Do you want a prod stage? Excellent, cool. Do you want to put some testing in this as well? It's a bit of a longer process than the original SAM init. But again, it's prompting you for best practices. It's making life easy for you to do things right. So your product is probably 75% of the way to going live. So at this point, you want to probably start working out, how am I going to start deploying this and test and prod? That's when most people's MVPs become less pet projects and more dramas. Trust me, I've been there recently. So it's built my API gateway, it's built my Lambda function, and it's building my pipelines for me. What more do we want? Is there more? Yes, monitoring, I mentioned that earlier. And we briefly covered this in the demo. SAM init will automatically implement X-Ray for you. It will implement CloudWatch application insights and structured logging. But also, there's more. There's the ability to also view the SAM logs live. And AWS CLI has just released this, the tail function, but it will show you the SAM logs live as well. So, fun and games. You get to test it in the cloud and see the log files locally. Serverless? More like serverless worries. Yeah, okay, I knew the last one was too far. I think, yeah, this is the feature that a lot of you have been wanting to hear. Boyan was encouraging me to talk about comparisons as well. Now, originally I was going to talk about Terraform, Pulumi, CDK, but I'm not a Pulumi expert, so I would be a fraud to stand here and compare SAM to Pulumi, and the Terraform bit fell off the end. So I do apologize for that. However, I'm going to run a quick comparison of SAM versus CDK. Does anyone in the room currently use SAM? 1, 2, 3, okay, cool. The blue corner's, that red corner's not looking like it's got much weight at the moment. And how many people currently use CDK? Okay, cool, excellent. We've got a couple of traitors. My personal opinion between CDK and SAM is that they are both as good as each other. I'm not a software engineer. As you can probably tell, I'm an infrastructure engineer at heart. I've always been racks, switches, servers. I've cut my hands on a few racks as well. Virtual servers. Infrastructure is what I've grown up on. And that's why SAM appeals to me. It's for infrastructure techs. But the reason CDK appeals to some people is because they're more geared as software engineers. They write code day in, day out. So CDK has constructs. It has syntax that's similar to writing programmatic code rather than declarative language. SAM's more for serverless techs, serverless apps. It's in the name, it's the serverless application model. So you can write your CloudFormation on top of it, but ultimately SAM's for serverless applications. CDK, you can be used for anything. It's for general purpose IAC, and I'll admit that as well. You know, I have used CDK in the past, and I still do, begrudgingly sometimes. And I'll admit, it's better at some things than SAM that aren't serverless. We're good? Okay. So with that, the obvious difference is the syntax as well. The syntax is YAML and JSON, declarative languages versus actual Python and TypeScript or whatever other language you want to use. SAM's quick and agile. It deploys very snappily, very easily. But that's the problem. Sometimes it's too agile, too small, too lightweight. Whereas CDK is much better for large-scale deploys and complex environments as well. So they both have their places, their uses, and the horses for courses. But that's ultimately my review of CDK versus SAM. If you want some resources, you can either take a photo of the slide, we can click on the screen. You told me it was touchscreen. The slides will go out, right? Will you send the slides out?
Yeah, we can.
Perfect. Yeah. So how to get started, SAM documentation, repo of resources, and the developer guide. And then also, this time last year, I actually wrote a series of blog posts all about SAM, demystifying the SAM journey from everything from how to get started right up to the security and CI/CD pipelines, which is available both on my blog and community.aws. So they're also available as well if you want to read further as well. Thank you. Did I go over? I wasn't timing myself.
Maybe we have a few minutes if anyone has any questions.
Sure.
Why are you not using ARM images for local development on your Mantel Pro?
Why am I not using? Why am I not using what? Sorry.
ARM architecture of processor for your images.
Great question. I don't know if anyone saw this, and I was wondering if somebody picked up on it. My demos were actually done on a Windows box using WSO. So there you go. There's another interesting fact about SAM. It works both on Mac and Windows. Any other questions?
Any topic-related questions? I mean, obviously want to ask about your experience with Amazon Q, but it's not.
My experience with Amazon Q has been wonderful.
I have a question on SAR,
On?
Serverless Application Repository.
Okay, try me, but again, I'm not an expert.
So we used to create reusable patterns and then use SAR to publish, and then we import that SAR, override a specific Lambda function to put in a specific instance for the template.
Yep.
So we went that far, but then we had to back off. Is SAR a continued investment from AWS? What's its future? Is it worthwhile going into that?
I can't answer that today, but it's a great question. But unfortunately, I can't answer that. I don't have enough information about SAR at the moment. I understand, I know what it is, and I didn't realize that it was as abandoned as it sounds. So, cool.
Maybe I'll ask you one question. When do you think SAM shouldn't be used? Like, from your experience, did you have any projects where you started using SAM, and then you found out that there was lack of some patterns, and you like,
If you're going down the route of something that's a little, I won't say less serverless, but if you're going down the route of doing things like Fargate containers, for example, you can do it, but I wouldn't. Something that's getting more complex than, say, single stack as well, because at the end of the day, SAM is based upon single template functions. So as soon as your complexity goes outside of one workload, maybe move away from SAM and start to think about Terraform or CDK and starting to modularize it as well. And that's one thing that disappoints me with SAM, is that it is designed for small, agile projects and not bigger infrastructure projects. I mean, I've got a couple of projects that I've run recently, and I can tell you now, I've got a template.yaml which is over 1,000 lines long, and it's starting to get a bit laborious to try and maintain. And so I would consider then separating it out into either a CloudFormation stack or using Terraform for it instead. So hopefully that answered the question. Cool. Joe.
With the local functionality, you mentioned like you can deploy a function and then use SAM to grab the cloud Will that CloudWatch stuff work with running it all locally as well?
So if you're running it locally, it uses its own local log engine. It's only when you actually run a what's called a SAM sync. So I kind of missed that bit in the CloudWatch logs part. So if you deploy, you can then run a command called SAM sync, which then, when it's testing in the cloud, will show you the CloudWatch logs over here instead. So it ties them both together. When you're running locally, the logs are just local instead on the screen. But the one thing I will say, if you do use SAM local and you expect to use it on an aircraft, make sure you cached your Docker image first. So,
Structured logging that we look at SAM,
yeah,
how does it compete with the Lambda Power Tools project?
it doesn't. If you've got a preferred technology, use that instead. Amazon's best practice for structured logging isn't always the best. I personally implement it myself because I've got my own preferences and patterns, etc. But if you're just getting started and you don't know where to start with logging, that's what that's for. So make sure that you've not missed it. But someone like you or me would go, I don't need logging, I'll put it in there, and then you forget.
There is also AWS SAM CLI for local stack
Yep.
as well, so that you can emulate what you're going to do in AWS
Yep.
locally, and it behaves just like AWS does from an API standpoint.
Yeah, licensing though. But yes, you're right. You can use local stack to help emulate further resources. But as I mentioned earlier, DynamoDB local is one to keep in the back pocket as well for if you are making DynamoDBs as part of your serverless stack as well. Cool.
Awesome. Thank you very much.
No worries. Thank you for listening.
So we do have one more speaker. And actually, by the way, how many of you came here? How many of you have Java background? Nice. Awesome. So I think most people came here for our second speaker. Yeah, probably if you want to grab another drink, I don't think we have much food left, but yeah, use this time. I think while Jason is going to connect his laptop. But our next speaker is from Mantel Group. Jason actually came from Sydney to present tonight, which is quite an effort. He's pretty much a polyglot lead engineer who's got experience in everything but .NET. And that was deliberate because there is a .NET user group happening tonight as well. So we didn't want to have any clashes here over programming languages. So and Jason has more than 15 years of experience leading a bunch of different projects at Mantel Group. And today he's going to present on the topic of Java and how Java can be used in the serverless environments. Yeah, and by the way, if anyone wants to sit, we do have a few chairs here as well, because I know that you've been staying for a while. Unless it's your choice. You want to finish this one?
Serverless Java, which is mostly a surprise for anyone. Like those two words, serverless, Java, normally don't associate together. Whenever, within Mantel Group, we've been a lot of projects, half of them are serverless normally. And yes, in fact, we don't think we have any Java project with serverless yet. But since this, for the last 2 years, I guess, a lot of change been made in Java, and it is possible today for that. So I'm gonna show you some evidence there, so stay with me. Yeah, I'm just, for myself, I'm a lead engineer in Mantel Group. I've been with Mantel Group for a while, went through different projects, a lot of frameworks, and both front and back ends. Yeah, quite a, I guess, long list of experience. And before I jump in, I'm gonna do a quick survey. If any one of you are platform engineer, DevOps, or cloud GUI dealing with YAML every single day. Cool. And anyone of you are dealing with semicolons every day? Nope. Cool. Awesome. All right. Cool. So serverless. Again, as I mentioned, whenever we're talking about serverless, everyone associates with Golang, Node, Python. That poor Java is, down there. Yeah, no one talk about it. Reason being, everyone knows it's code start is super slow, and unless you are working on a asynchronous structure, but in a synchronized way, it works. Otherwise, if you do want to have a customer-facing API, you're probably not going to go down that path. Your customer will be super unhappy about that. And in fact, this is some data showing the cold start delay for all the language there. The top one, obviously, that's Java. And the second one is .NET. I just threw it for fun. Don't worry about that. And the Go, Python, Node, you can see the performance is pretty awesome. We're talking about Java is probably 10 times longer than Python, which is kind of the average industry. So with that, what been recently happened is this one VM called GraalVM. It's, first of all, it's from Oracle. It's not some dummy two guys working in a hobby project bring on a VM. So it's a full project being supported by a proper company there. And what GraalVM can bring, it's a fast startup for Java application. That doesn't matter it is running in serverless or not. I'll show you some evidence there, that's real data. Also, it's a lower memory footprint, JVM, which is consuming a lot of memories, and that's one of the reasons it's start super slow in serverless. And another big feature coming from GraalVM is this AOT, which is ahead of time compilation. So just gonna touch a little bit on this one for those not quite familiar with Java, I guess. When you write Java code, it's .java file. That's what you're writing in your IDE, in your text editor, in your Vim. And when you actually do compile, which is normally Java C, when you compile, it will compile to a Java bytecode, which is .class file. And that will eventually deploy to the JVM. And within JVM, that's what the JVM is actually holding the file and eventually will run. But that's not what the machine can understand. The machine gonna understand the machine code. What that means at the time when your application running in JVM, the .class file will be recompiled again by the JVM to machine code. So this is why when JVM applications start up, it's slow because at the initial time start up, it has to compile a lot of code to machine code. So quickly have a comparison of both the just-in-time, that's basically the JVM, the one been there for 20 years, I guess, and the ahead-of-time compilation. So the difference, the first one, at what time this get compiled, the JIT, which is at runtime, the one I mentioned when your application is running, that's where it compiles to machine code. And the AOT is actually at the build time, which means at the time when you build your application, your project, it will become a machine code. So you don't actually need to run within the JVM anymore. So which touch on the execution model, and the JIT, it takes the bytecode, compile to machine code during runtime. And the AOT, that's machine code already ready before the runtime. Performance-wise, It's bit overhead for JIT at start time due to the compilation. And for the AOT, that's basically at the time it just starts without any compilation because everything is already there. And so far, AOT looks good. However, there is some issues there, which is kind of what Java was trying to solve 20 years ago. So the JIT is platform independent. You write your code. I think what Java backend says, you write once, deploy everywhere. That's what they say. However, in AOT, it's different because it is machine code. So at the time when you build your application, it has to know where your application is running. Is it an M1 machine? Is it an ARM machine, Intel machine? So that's kind of back to the C++ time. So that's one drawback. And memory usage-wise, obviously, for JIT, at compile time, it's small. Reason being, it just compares to bytecode. However, at runtime, it's kind of meaty in a way. It uses quite a bit of memory there. For AOT, at compilation time, because it's going to compile to machine code, so that's why it's used quite a bit memory, and also it actually taking a while to compile. Oops. And obviously, at runtime, it's small. So what happened after the group VM compiled the code to compile your code to machine code? Basically, what's being compiled into it's a standalone executable. So think of when you run this code. Normally, when you run your Java, will be, for example, Java-jar with your Java file. That's how your Java application starts. With this one, // whatever the compiled file. Then that will run in your machine. And secondly, it doesn't run on any JVM because it's already machine code. Faster startup, lower memory overhead. With that, let's look at this one again. The Java still quite long, .NET still there for fun, Go, Python, Node.js, and the last one is GraalVM. That's where it's sitting. It's only slightly longer than Python. That's where this Lambda code starts. Cool. So if you're thinking, all right, that's awesome. How are we going to build an application with GraalVM? There are a few famous frameworks out there. The first one, whoever in the Java world probably already know this. That's Spring. And then Quarkus, which is from Red Hat, I think. And Micronauts, and a few here. So these are the popular frameworks out there currently in the market. And each one of them have their own way to write your Java code, or in a way, some are always making fun, you have your own way to write your annotation in Java, and which eventually will get compiled by GraalVM into the executable. So my case, I will show you guys a code example, which is actually built on Spring. So it's probably the most famous one. So quickly touch on how the build process works. So after the Java C, you got the .class file. And any one of those frameworks with either Maven or Gradle, A will build the jar. Depends on how you're going to optimize that. If you're using just JVM, obviously A will just be the normal jar file, which you're going to have to deploy in JVM in order for it to run. But if you build with GraalVM, A will come with a GraalVM native image. It's one executable, and that can be run in the platform you built for. Cool. So I'll quickly show some code. So this is a very simple hello world. So we got an actor or user here. What it's trying to do is try to call a REST API. And the REST API is basically providing the airport informations. And what that airport service does is actually retrieve those information from an external endpoint. So basically, the application we are focused on now is the box in the middle, the airport service. So some code to here. This is a very standard Spring Boot. By the way, this, if you're a Java engineer, you're probably very familiar with this. This got nothing to do with GraalVM with native image yet. This is just standard Spring Boot. We've got a REST controller at the top, which is accepting the GET request with the airport URL, and it's calling a service, and the service is calling the repository, and the repository will actually call the REST client. The REST client will go to someone else to fetch those information back. Kind of a standard Spring MVC pattern. Yeah. And on the right-hand side, that's basically what the model is. That's the airport. It shows the code, the name, blah, blah, quite a few information there. So this is a standard, again, standard Spring Boot application. If you build this, you run, what will happen? You use Gradle, for example, you do clean build and Gradle boot run. That's the standard way. You build your Gradle Spring Boot Java application, and the application started at 1.255 seconds. I'm pretty sure I was using an M1 Mac 32 gig machine. So that's in my machine, that's a start time. And you hit the endpoint, it will return some of the airports. So simple. So a lot of applications, the existing one you are already building, it may look like this, very familiar. So how are we gonna, I guess, make this one to a executable, super fast startup Java application? This is what we need. First thing, instead of Gradle clean build, we just Gradle clean native compile. That's the first one. And the second one is after the compile, it will basically generate a executable file. Here we just simplify it to call app. And it's under this path. And basically now we just try to run this application. First of all, this build, it may take 2 or 3 minutes. It is taking a bit long time to build. However, if you want to run this application now, check how long it takes to run. It's 0.071 seconds. If I bring up the previous run, you can see the difference there. So again, if we look at this, have we changed any one line of the code? No. The only difference is how we compiled it and how we actually run it. And that's a difference. Yeah. So again, so far, nothing with serverless yet. It's a Spring Boot application. Instead of building in Spring Boot, we're building in what they call Spring Native, but basically its underlying is GraalVM. And that's what we got. You probably are going to tell it's awesome. Cool. So that application I just showed, we did deploy it into AWS. We did deploy it to Lambda. And we're using K6 to run a lot of testing. And this is the data we found out. So the first one is Spring Boot code. That means it is the Spring Boot, which is generated a jar. We deploy it to Lambda. And we try to run a test, cold start. And then we delete the Lambda. We recreate the Lambda. We cold start test again. And after thousands of tests, that's the time we get. The time means from my local machine, I hit that get airport endpoint, and that's how long I wait until the airport information coming back. And actually took 15 seconds for a cold start Spring Boot application. And on comparison with that, again, same code, Spring Native, deploy to Lambda, exactly same process. It took 1.5 seconds to get the response back. Again, the time difference, 10 times, if my math is correct. And those two are the cold start for Lambda. And then we've done intensive testing for the warm Lambda testing. So the difference is still quite significant. I would say it's half of the time. Yeah, so with this, that means if you have an existing Spring Boot application, if you want to get the benefit of quick start in not limited to serverless, literally anything, you don't necessarily have to change your existing application. You can simply find a different way, this way, GraalVM, to build or compile your project and eventually deploy. And that's the difference you're going to get. And yes, we're software engineers, so we're using CDK. So this quickly show, this is the way we deploy the Lambda. So I think that's basically all the standard ones. Just one thing do need to point out is, I'm not sure you can read it here, but when you try to build the image, you have to have a special image, which is the AL2 with GraalVM. So I think nowadays it's already provided default by AWS, but at the time when I was doing the testing, it doesn't, so I have to kind of grab the AL2 image and adding the GraalVM and put it back. So that's why it's under my namespace. But yeah, other than that, this is basically how you're gonna deploy the application to Lambda. Cool. That's actually all from me today. For us, thanks. So the example I just showed is basically kind of the first link, which is a Spring Native. We do have other project there, which is using the Quarkus, for example, and a few blogs, and also the GitHub links, which is the exact code I'm showing here. It's there. You can download. Obviously, you need to put in your AWS credentials, blah, 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 and you can make it run and try it out. And that's all for me. Thanks.
Are you happy to take a few questions?
Yeah, sure.
Is it a runtime available in Lambda, or is it an image that we have to use it against Lambda?
It's a compile time. Yeah. So
Compile time?
yeah, and that's it.
And then you create an image and then make it over?
Yes. Yes. Yeah.
And GraalVM, what's support for OpenJDK Oracle licensing wise? How does it work?
It's supporting two versions. I'm pretty sure one is Java 17, one is Java 21. It's kind of like two layers. I know today it's Java 22, it's out there, so I assuming they will be soon support that. Previously, it was more like a long-term support stable version, Java 17, and then more like a cutting edge, the latest Java version. Yeah.
Have you benchmarked it against Snapstart, Amazon's kind of Java optimizations?
Good question. We should. So this evaluation actually happened 2 years ago. Back then, Lambda hasn't had that yet. Yeah, so we didn't actually benchmark testing with that one. Yeah.
What is your experience? Because I think you mentioned that you use Snapstart.
Yeah, we use Java and Snapstart. It's pretty good. It gets our code starts below a second, and it's one extra argument added deployment. It's quite good for us.
Cool. All right. I get. Cool. Thanks, everyone.
We can keep this later on. I don't have much to say. But yeah, actually, if you want to work at Mantel Group with him, please reach out to myself. I will forward it to our people in culture. Thanks for coming. I think our next meetup will be in roughly 3 months. We're trying to run them quarterly, so I think the next one will be probably September. And it seems like we do have speakers for the next one, which is great. But if you want to present, please reach out to me. We're probably going to have another one just before Christmas. And yeah, if you want to share anything related to serverless, it doesn't have to be AWS. It happened to be AWS today and many other days, but it doesn't have to be AWS. Thanks for coming. Please, I think, yeah, you can stick around for maybe another like 20 minutes, and then I think we're going to wrap up.